The following Zoom session is being recorded and will appear later today on my YouTube channel, Math with Mayo. There are two different classes that may be observing this session. Therefore, when you participate in the Zoom meeting, if you do not wish for your picture or your name to be made public, please leave the video off and use an alias name. If you have questions during the meeting but do not wish to speak, email me at bmail@ybcc.edu and I'll respond as soon as I can. Okay, so we're going to start out with a question that was requested. Actually, I just want to mention a couple of things. Some of you, maybe not anybody that's here right now, but some of you call me and I want you to email me, not call me, okay? Secondly, when you call, I don't know who you are anyway, because there's no thing there, so I don't respond. And if you do call and that's the way you're going to communicate, leave a message. Secondly, I've still got some of you sending me messages through WhatsApp. Don't do that. Email me. Okay. All right. Also, I'm going to be switching back and forth between screens a lot. So if I'm talking about something and I'm on the wrong screen, please jump right in and say, hey, you didn't push the right button. Okay. So this is a question that was requested from one of you. So let's take a look at it. This is from yesterday's homework, objective 2A, number 16. The directions say, convert 2/5% to a fraction or mixed number. So we have 2/5%. I'm going to use the method I introduced yesterday. I need to get rid of the percent, so I'm going to multiply it by 1 over 100%. So now the units of percent on top and bottom cross out. I have 2 times 1 over 5 times 100. I can further reduce. 2 divided by 2 is 1. 100 divided by 2 is 50. So now I have 1 times 1 over 5 times 50, 1 over 250, final answer. Okay. Again, it's a fraction. It's a fraction or a mixed number. Any questions about that particular problem?
No, that was like total light bulb moment right there.
Excellent. Whoa, that light bulb's so bright. Okay. I want to talk ever so briefly about your test. I haven't finished correcting all of them. I've looked at about half of them, but these were things that I noticed students missed a lot of problems because they didn't follow the directions. We'll get to that in a minute, but a lot of you missed, there was a problem that was something like, oh, let's say 6 less than 3 times a number. And it might have been, the numbers here vary, different people had different numbers, but less than means you're taking that first thing away from the second. So like this would be 3 less than 7. Okay, 3 less than. So 6 less than 3 times a number would look like that. 6 less than, so you're taking it away from 3 times a number. Okay, so we need to work on that. Now, quite a few of you missed problems because you didn't follow directions. You gave an answer, like for instance, maybe it asked for an improper fraction and you gave a mixed number, or maybe it asked for a mixed number and you gave an improper fraction. So read carefully. Again, let's look at examples of those. A proper fraction is where the numerator is smaller than the denominator, so like 3/5. An improper fraction is where the numerator is either equal to or larger than the denominator. So like 3/3 is an improper fraction, 4/3 is an improper fraction, 17/16 is an improper fraction. Okay, mixed number, you have a whole number part and a fraction part, and the fraction part should be reduced. So you wouldn't have like 4 3/2. You'd change that into 5 1/2. Anyway, any questions about that right now? Okay, then let's go ahead and move forward into today's lesson, which is section, let's see, it's objective 2B.1. I believe there's 0.1, 0.2, and 0.3. Yes. All right. And we're going to deal with ratios, unit rates, and unit price. So those are our three similar topics for today. Okay, now let's see if I can do this correctly. So what I'm going to do first of all, I'm going to go to WAMAP and take a look under textbook materials. Okay, and down here at the bottom it says Pre-Algebra Chapter 1, Ben Mayo. Okay, and we're going to take a look at some definitions. I'm going to use the stuff from my textbook here. Now, let's take a look here. First of all, we're going to deal with the idea of a ratio. It says a ratio is a comparison written as the quotient of two numbers, or as the quotient of two quantities with the same units. It says the ratio of 1 to 16 can also be written as the fraction 1/16. Okay, now there are other ways of writing it using a colon and all kinds of things, but we're just going to stick with the word 2. So example 1 says, oops, write the ratio 4 to 18 as a fraction in lowest terms. The number that comes first goes in the numerator, so before the word 2. The number that comes after the word 2 goes in the denominator. So solution 4 to 18 becomes 4 over 18, which can be reduced by dividing both the numerator and the denominator by 2. So 4/18 becomes 2/9. Therefore, the ratio is 2/9. Any questions so far? All right, going on. When writing a ratio as a fraction, the first number is on top or in the numerator, the second number is in the bottom. I already mentioned that, but let's take a look at example 2. Write the ratio 18 to 4, and it uses a colon, my apologies, but let's 18 to 4, as a fraction in lowest terms. All right, now the point of this that I want to make is, so we get 18 over 4, which reduces to 9/2. Therefore, the ratio is 9/2, okay? Note, in its simplified form, a ratio should be expressed as a quotient of two whole numbers. I can't say the word. Consequently, a ratio that is an improper fraction should not be converted into a mixed number. So if you took the ratio of 9 to 2, and you can't see this because I haven't switched it over. You take the ratio of 9 to 2, and you write it as, let's see, that would be what, 4.5. That is incorrect. Okay, a ratio in its lowest term should be a whole number compared to a whole number. So in a final answer, you wouldn't have a mixed number. All right, any questions about that? Okay, so what I want to do now is I want to look at some examples. So let's take this. It says, write each ratio as a fraction in lowest terms. We have 6 to 14. So writing as a fraction, it would be 6 divided by 14. By lowest terms, it means that we are to simplify, reduce this as much as we can. Keep in mind, in the final answer, there should be a whole number on top and a whole number on the bottom. Since 6 and 14 are both even, we could divide both the numerator and the denominator by 2, and we'd get 3/7 or 3 to 7. So that would be the simplified form of that ratio, because I can't reduce it any further. Any questions about this example? Okay, let's take a look at another example. 13 to 26. So write this ratio as a fraction in lowest terms. Well, it turns out that if we do the prime factorization, 13 is 13, and 26 is 2 times 13. So I could reduce the 13 over 13 to 1 over 1, and now I have 1 over 2. So the ratio of 13 to 26 could be expressed as 1/2 or 1 to 2. Okay. Any questions about that example? All right. How about this one? 6.2 to 4.8. So write it as a fraction, 6.2 to 4.8. We want it in lowest terms. We want a whole number on top and a whole number on the bottom reduced as much as possible. I have decimals. I need to get rid of them. I need to move the decimal one place on the top and one place on the bottom. Whatever I do to the top, I have to do to the bottom. If I multiply the top by 10 and the bottom by 10, we talked about yesterday, multiplying a decimal number times 10 moves the decimal point one place to the right. So this would become 62. And on the bottom, one place to the right, this would become 48. I'm not done though. So I've written it as a fraction. I've gotten rid of the decimals, but I need to simplify it further. Again, do not write it as a mixed number. Can I reduce this thing? Well, let's see. For starters, both 62 and 48 are even. So let's divide both the top and the bottom by 2, which gives me 31 over 24. Can I reduce that further? Well, it turns out that 31 is prime, so I can't divide it down, divide it by 2 or 3 or something. So this would be my final answer. A whole number divided by a whole number, and it can't be reduced further. And again, do not change it to a mixed number. You're probably wondering, why do I keep saying that? Well, your predecessors have had a history. We'll just leave it at that. Okay, any questions about that one? Let's take a look at this one. 7 to 35.7. So writing it as a fraction, it would look like that. The numerator is fine, but the denominator has a decimal. So to get rid of the decimal in the denominator, I'm going to have to multiply by 10 to move it one place to the right. But whatever I do to a fraction's denominator, I must also do to its numerator. Okay, so now I get 70 over, let's see, this is going to move it one place to the right, 357. 357. Wow. Is that primed? Is it factor? Here's what we're going to do. Okay. For a fraction to reduce, it must share a common factor in the numerator as well as the denominator. Let's take the easier of these two, 70, and let's break it down into prime factors. 7 times 10, 7 times 2 times 5, which we'll write from smallest to largest. So the numerator is 2 times 5 times 7. Okay, any questions so far? Now, I said a minute ago that for this to reduce, it has to share a common factor, the numerator and the denominator. Since the numerator has a 2, a 5, and a 7, and that's it, all I need to do is take 357 and see whether 2 or 5 or 7 goes into it. Okay? Well, let's see, 357. It's not an even number, so 2 doesn't go into it. If 5 went into it, the number would have to either end in a 0 or a 5, and it doesn't. So 5 doesn't go into it. So all that's left is 7. Let's see if 7 goes into 357. Well, 7 goes into 35 5 times. 7 goes into 7 once. Oh, so this would be 7 times 51. Now, 51 is not prime. 3 goes into it, but here's the deal. At this point, I can get rid of the 7s. Does 2 go into 51? No. Does 5 go into 51? No. So I've reduced it as far as I can. 2 times 5 is 10 over 51. Now, incidentally, 51 is 3 times 17. But again, there's no 3s or 17s in the numerator, and there's no 2s or 5s in the denominator. So there we have it. I threw a lot at you there. Do you need a minute to kind of absorb that? Apparently not. Okay. We'll go on. Let's take a look at this example. $1.25 to 75 cents. So we'll write it as a fraction. Okay. Now, I can cross out the common units of dollars on the top and the bottom. So I've got 1.25 over 0.75. I'm going to multiply by 100 over 100. That will move the decimal point 2 places on the bottom and 2 places on the top. So I get 125 over 75. I can reduce it. Can you see that 25 goes into both 125 into 75? You see that? So let's divide the top and the bottom by 25. It goes in 5 times on top and 3 times on the bottom. Five-thirds doesn't reduce further. There's my final answer. So the ratio of $1.25 to 75 cents is 5 to 3. Any questions on that? Okay. Let's take a look at this example. 2 cats, 7 cats. What is the ratio of 2 cats to 7 cats? Well, 2 cats to 7 cats. Cross out the common units. Final answer, 2 to 7. A ratio in its final form should have no units because there would be common units that would be crossed out in the simplification process. So a ratio, you wouldn't say the ratio is 2 cats to 7 cats. You'd say the ratio of the cats is 2 to 7. Okay, so no units in the final answer of a ratio. Because if the units aren't the same or can't be changed to the same, then it's not a ratio, it's something else that we'll be talking about soon. Okay, let's take a look at this. 1/5 to 0.6. Now, I need to write this as a fraction, and I could start out by saying, well, 1/5 over 0.6 and go from there, or I can do some simplification first. It might be best to have them both as decimals or both as fractions. So should we write them both as a fraction to start with or both as a decimal? Anybody, any ideas? It's not a wrong answer. Either one we can do.
Decimal.
Decimal. Okay. So then the question is, 1/5, what is that as a decimal? 1 divided by 5 is 0.2. And I kind of zipped through that quickly. Are you okay with how I did that? Are you all right? So now I've got 0.2 to 0.6. So there's your fraction. I'm going to multiply it by 10 over 10, which is going to move the decimal point 1 place on the top and 1 place on the bottom. So I get 2 to 6 or 2/6, but I could reduce that down to 1/3. So 1/5 to 0.6 is a ratio of 1 to 3 or 1/3. Okay. Let's go back and let's do this same example, only this time, instead of using two decimal numbers, we'll use two fractions. Are we good to go on? Okay. So 1/5 to 0.6. Well, so 0.6 is what as a fraction? Well, what's the correct name for that? There's a 6 in the 10th spot, so this would be 6/10, which could be reduced down to 3/5, right? So 0.6 is 6/10 is 3/5. So now I've got 1/5 to 3/5. Well, let's write that as a fraction. 1/5 to 3/5. Oh, but wait a minute. In the final answer, it needs to be a whole number over a whole number. So we're not done yet. Well, this is the same thing as 1/5 divided by 3/5, isn't it? But what do you do when you're dividing by a fraction? You multiply by its reciprocal. Okay. Then I could reduce this down and I get a final answer of 1/3. So there you go. Same answer as we got before, just a different approach. Now, can you always do this? Well, where you might get into trouble is if you've got a fraction that you're changing to a decimal and it ends up being a repeating decimal, okay? Then you can't really deal with it. So you want to avoid repeating decimals in this context. In that case, I would write them both as a fraction, okay? And you'll know if you try and take it and it ends up being repeating, it's like, oh, I got to go and do it the other way. All right. Let's take a look at one more of these and then we'll move on to the next idea. Let's say we've got 5 1/3 to 4 2/3. Okay. Well, we could change both of these mixed numbers into improper fractions. 5 times 3 is 15 plus 1 is 16/3. 4 times 3 is 12 plus 2 is 14/3. Okay. And then I could write it as 16/3 over 14/3, which is 16/3 divided by 14/3, which is 16/3 times 3/14. I know you're thinking, does this problem ever end? Now, the 3 is reduced to 1/1. 16 divided by 2 is 8. 14 divided by 2 is 7. So we end up with 8 to 7. So the ratio of 5 1/3 to 4 2/3 is 8 to 7. Any questions about any of the steps there? All right, give me just a minute here. Okay, let's see here. Here we go. All right. It says, we're going to look at Janet's monthly budget. Okay. Based on Janet's monthly budget, answer the questions. Well, let's take a look at problem number 59. What is the ratio of food cost to transportation cost? So food is $400. Transportation is $150. So the ratio would be $400 to $150. Everybody okay with that? All right. So let's take that and deal with it. So $400, oops, I've already got that. $400 to $150. I could cross out the common units. Do you know about how to get rid of zeros? For instance, if I divide 400 by 10, it gets rid of one of the zeros. 150 by 10 gets rid of one of the zeros. Is everybody comfortable with that, or do I need to go into details there? We're okay? All right. Well, let's see. What have I got? I've got 40 over 15. Oh, but 5 goes into both of those. 40 divided by 5 is 8. 15 divided by 5 is 3. So the ratio of food to transportation is 8 to 3. Are you okay with that example? Any questions there? Okay, let's see
So when
here.
you get rid of the zero and the first step, you don't have to show it.
No, you don't have to show it. I mean, basically, I would think you would want to cross it out so that you know that you've gotten rid of it. So, I mean, what do you mean by showing it? Showing, going through the process of
Like
400
showing,
divided by
yeah.
10. No, this is,
Yeah.
I mean, yeah, that's fine. You're dividing the top and the bottom by 10.
Okay.
Okay. All right. Let's see here. So now we're going to talk about, let's see here. Get the right thing. Unit rate. Okay. A unit rate is a rate in which the denominator is a single unit. Now, this particular set of exercises doesn't talk about just plain rates, but I want to go back and talk about a rate for just a minute. A rate is a comparison written as the quotient of two quantities with different units. So how does a rate differ from a ratio? A ratio is either a comparison of two numbers, or initially a comparison of two numbers with units attached, but they're the same or compatible units. So in the process of simplifying a ratio, we get rid of the common units. Okay. A rate, we can't do that because a rate, the two different quantities have different incompatible units. So in the final answer of a rate, the units are still there, like miles per hour, feet per second, chickens per hen house, or whatever. Okay. Now, we're going to look specifically at a unit rate. A unit rate is a rate in which the denominator is a single unit. So unlike a ratio where we try to get it a whole number compared to a whole number, with a unit rate, we get so much of one unit per one of some other unit. So the numerator might be a fraction or a mixed number or a decimal. Okay, so it's a kind of a different ball game. So unit rate is a rate in which the denominator is a single unit. Let's take a look at example number 6 there. A man earns $46 in 8 hours. What is his hourly rate of pay? So it's going to be so much per hour because it's hourly rate. So 46 in 8 hours, $46 becomes $46 over 8 hours. Okay. The denominator needs to be a single unit. This can be accomplished as follows. We're going to divide both the top and the bottom by 8. Okay. So 8 hours divided by 8 and the bottom gives us 1 hour. $46 divided by 8, we get $5.75. Therefore, his hourly rate of pay is $5.75 per hour, and that is a unit rate. Okay. Let's look at one more example here, and then we'll go and work some out. Longhand, I will. A car travels 282 miles on 9.4 gallons of gas. What was the car's fuel efficiency in miles per gallon? Now, it doesn't specifically say write it as a unit rate, but because it's miles per 1 gallon, and miles and gallons are not compatible units, you can't like get rid of them. Our solution, we've got 282 miles on 9.4 gallons of gas. You write it as a fraction, but the denominator needs to be a single unit. So we've got to divide both the numerator and the denominator by the 9.4, okay? 9.4 gallons divided by 9.4 is going to give you the 1 gallon. In the numerator, we've got 9.4 divided into 282. Now, I didn't cover this yesterday. I don't know if you know this from the past, but when you're dividing and you've got a decimal number on the outside, you have to get rid of that decimal. So we have to move the decimal point 1 place to the right to get 94, which means we also move inside 1 place to the right, which adds a 0. Okay, any questions about that? 94 divided into 2,820 is 30. So therefore the car's fuel efficiency is 30 miles per gallon. Any questions about that? Okay. Let's take a look at some more examples. Let's see here. Unit rate. How about 18 cities in 8 days? Okay, so 18 cities in 8 days. We want an answer that's so many cities per day because we're looking for a unit rate. Okay, so if I divide the bottom by 8, that's going to give me the 1 day I desire. So I've got to divide the top by 8 to figure out what goes on top. So I've got 18 divided by 8. Okay, goes in twice, 16, 2. Now, this particular set of directions, it just said, write each expression as a unit rate. It didn't say that the numerator should be a decimal or a mixed number or an improper fraction. If I went as a mixed number, I would have 2 2/8, which could be reduced to 2 1/4. Okay, so that is a correct answer. Any question about that? Or I could do this and I could say, well, I'm going to go with a decimal. And I could get 2.25 cities per day. Now, in WAMAP, on a specific problem, it might say use a mixed number, use a decimal. If it specifically asks for one and you give the other, even though they're equivalent, it will mark it wrong. So you got to follow the directions. When all else fails, read and follow the directions, okay? Or maybe even before all else fails. Any questions about this example? Okay. Let's take a look at another example. This says, let's see here, 112 miles on 4 gallons. And we want a unit rate. So 112 miles, 4 gallons. I want my final answer to be so many miles per gallon because it's asking for a unit rate. So what am I going to do? Well, I'm going to divide the top by 4 and the bottom by 4. So the bottom is going to be 1 gallon. Okay. 112 divided by 4 goes in twice, 8 times. So 28 miles per gallon. All right. Any questions there? So now let's take a look at our third idea. Let's see here. Okay. Unit price, or sometimes it's called unit cost. A unit price is a rate in which the numerator contains an amount of money and the denominator contains a single unit of some type of item. So 30 miles per gallon is a unit rate, but it's not a unit price. If it was $4.87 per gallon, which is probably about what gasoline is now, that would be a unit price. So a unit price is a unit rate where there's money in the numerator. Okay. All right. Let's take a look at some examples of that. It says, write each expression as a unit price. $87.50 for 7 CDs. Okay, so I've got $87.50 for 7 CDs, and I want to know the price per CD. Okay, now I can accomplish this by dividing the bottom by 7 and the top by 7. The bottom 7 CDs divided by 7 is 1 CD. The top, we've got 87.50 divided by 7. Now, a little bit ago, I did an example or showed an example where there was a decimal point on the outside of the division. Okay, if there's a whole number outside, we don't have to fix the decimal inside. We just bring it straight up. But if there's a whole number or a decimal outside, you got to move both up. So my decimal point's going to go right there. We okay? Far? 7 goes into 8 once. Bring down the next number. 7 goes into 17 twice. Bring down the next number. 7 goes into 35 5 times. And so we get 12.5. Now, mathematically, that answer is correct. But society-wise, we would write it this way, wouldn't we? You wouldn't say $12.5, you'd say $12.50. Any questions about that? All right.
The long division really necessary? Can we just use our computer or our calculator?
Absolutely. Here's how I'm going to handle the calculator. If you ask, I'll tell you about it. If you have something you're not sure how to do on the calculator and you ask about it, I will explain it. But otherwise, I'm just going to do it by hand to reinforce that idea of it. Absolutely. But if some of you are relying on the calculator and you're struggling, ask me and I'll be happy to bring up a picture of a calculator and point on buttons and everything. I just don't want to focus on that unless you need it, but I'm absolutely willing to do it. Okay, Courtney? You betcha. You betcha. So yeah, you could do 87.5 divided by 7 and boom, 12.5. Okay. Yeah. I might even have done that myself on occasion, but I would never admit it. Okay. How about, let's see here. Just a minute. I want to look at something. Okay. All right. Actually, I think I'm on the white screen now, aren't I? Yes, I was. What we're going to do, we're going to compare 3 different items and find the unit price of each to determine which is the best buy. Okay, when you go into a grocery store, and let's say you're going to buy a box of cornflakes, okay, and there might be 6 different brands of cornflakes, and each brand has 2 or 3 different sizes of boxes. Okay, I see that yawn, Courtney. Come on, wake up, wake up. This isn't the most exciting part of your day. Don't answer that. Don't hurt my feelings. Okay. Anyway, and you're looking at all these cornflakes, and it's like, what do I get? I don't know. And there's something called a unit price. It's a little sticker. I believe it's black and yellow, and it's at the bottom below each of the different kinds of cornflakes. And it has a unit price written typically in cents per ounce, at least for something like cornflakes. But it might be dollars per pound, or, there's a variety of different unit prices. But by looking at those, you can see which is the best buy. Now, let's say you're going to buy a particular brand of cornflakes. Well, there still might be 3 different sizes, like a 16 ounce, a 12 ounce, and a 8 ounce or something. You can look at the unit prices to see which is the best price per ounce. The least amount of money per ounce would be the best buy. Okay, so we're going to do that without looking at the black and yellow sticker. Okay, we'll see. We'll go behind the scenes. And again, Courtney, absolutely, you can use your calculator in this one. Okay, I'm going to do it the long way just because I love to torture myself, and you as well. Let's say we have the following. So we've got toasted oat cereal. We've got 10 ounces for $2.28. We've got 15 ounces for $2.69. And we've got 20 ounces for $3.99. Okay. It says, find the unit price of each item. Rounding answers to the nearest cent. Determine the best buy by comparing results. Okay. So let's take the first one. I have $2.28 per 10 ounces. Dividing by 10, I would be wasting time using a calculator. What does it do to the decimal point? It moves it 1 place to the left, right? So this is going to be that. Now, be careful. How much money is in the numerator there? How would you correctly say that? Or how would you?
23 cents.
It's how much?
23.
Okay, but what's showing right there? It would ultimately be that, Whitney, but what is there right now? What's circled? How much money is that?
22.8.
Right. And notice 22.8 cents, right? So this is written with a dollar sign, but this is like, what? This is 2 dimes and 2 pennies and 8/10 of a cent. So my point is this. Rounding to the nearest cent, because our units are in dollars, it's a little deceptive as to where the cent is. It's right there, the 2, right? So this would round up. So you'd have, like you said, you'd have 23 cents per ounce, right? We okay with that? All right, so this is what we'll say per ounce. All right, let's take this one. Now here, it's not so quick and easy to do. So 269 divided by 15, tell you what, for the sake of time and to make Courtney happy, we'll use the calculator, okay? Because when Courtney's happy, we're all happy, right? And she's thinking, just leave me alone. It's too early in the morning. 269 divided by 15. This is what I get. 0.17933, and it goes on and on and on. Okay. So which one of those numbers is the cent column? Is it the 0, the 1, the 7, the 9, the 3? Which number is the cent?
The 7.
Correct. The 9 would round up or down? Up. So we're going to get 18 cents per ounce. Okay. Let's take the last one. 3.99 divided by 20. Let's see here. We'll use our calculator again. 3.99 divided by 20. And I get 0.1995. So what number is in the cent column here?
The first 9.
Correct, the first 9. So this 9 would round up and we'd have, so this is what, 20 cents per ounce. So the first one's 23 cents per ounce, the second one's 18 cents per ounce, and the third one's 20 cents per ounce. Which one is the best buy?
15 ounce.
Yeah. And you'll find it's not always the biggest one that's the best buy. All right, I have one more thing to leave with you before we go. If we were in the classroom, I have a picture on my computer that shows a sign of a certain taco sales place in town that might rhyme with taco brime, but I won't mention it for, I don't want to get sued, but they had a sign that said taco. This was on Cinco de Mayo, of course, my birthday, Cinco de Mayo. Well, not really, but anyway, it's tacos, and it had this price. My question to you is, how much is that? Not how much do they intend it to be, but how much money is that?
Half a cent.
Good job. It's half a cent. Now, what they should have done is either written that or that. This is 50 cents. Technically, even though we call that 50 cents, it's 50 hundredths of a dollar. But we don't say that. We say 50 cents. But the problem is, because we see this as 50 cents, and we see that as 50 cents, sometimes we get confused and people write that. I've seen a lot of signs places where, if I brought my lawyer in, I could have made a killing on a good deal. The hard part is convincing them that that's half a cent. And I probably didn't make any friends that day. I told them, I said, you should fix your sign because I could bring all of YBC over and put you out of business at that price. And they said, well, our maintenance man is the one who changed the sign, blah, 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 whatever. Anyway, good for you, Courtney. All right, ladies and gentlemen, I bid you adieu. I will be back at 1:15 this afternoon. Should you have any further questions, we will stop the recording